Good evening. My name is Lance J. Brown, and I am the 2014 president of the New York chapter of the American Institute of Architects. This evening, we are more than honored to have the renowned architect Sir Norman Foster, honorary AIA, and engineer Roger Ridsell Smith here. They will share with us how the Guastavinos, whose patented designs include the Oyster Bar, St. John the Divine, Ellis Island's Registry Room, the Municipal Building, the subway stop at City Hall, and more and many more New York City landmarks in the hundreds. And they continue to inspire today's building technologies with all of their own designs. It's with personal and particular pleasure that I open this evening's discussion with Sir Norman Foster. His work, both process and object, have been of enormous influence on me and my generation. Buildings like the courageous Bank of Hong Kong and Shanghai, and edge-cutting urban investigations like Masdar City, and the absolutely breathtaking beauty of the Miao Viaduct illustrate his lifelong pursuit of inventive, innovative, humane, and beautiful environments for the world coming at us. My theme this year as president of the AIA New York chapter is civic spirit, civic vision. So it's a wonderful opportunity to hear about the innovative work of Sir Norman Foster and Roger Ridsell Smith and how they have learned from the Guastavino's public work. So many of the Guastavino projects are in fact civic in spirit and even from back then civic in vision. And they've defined so many civic spaces in New York City and around the world. Throughout 2014, three major New York institutions, the AIA New York chapter and Center for Architecture, the Museum of the City of New York, and the Spitzer School of Architecture will be hosting exhibits and programs that will celebrate Catalan architecture in New York City. These events serve as a foundation for the Barcelona-New York City Urban Bridge 2014, a year of Catalan architecture in New York. Defined by their grids and their wonderful waterfronts, Barcelona and New York are also distinguished by the passionate devotion of their dwellers to the life of the city and to the technologies we will see unfold between the Guastavinos and Sagrada Familia. Palaces for the People, the Guastavino of Art and Structure tile, runs at the Museum of the City of New York. It opened in March and it closes on September 7th, so you all have a chance to go there. Polis 7, Lessons from the European Prize for Urban Public Space, opened on March 27th and will close on June 21st, and it surrounds this gallery outside. And Gaudi's unfinished masterpiece, the Sagrada Familia, Space, Time, and Sight, will be a show at the Spitzer School of Architecture opening in the fall. This program is co-sponsored by the Museum of the City of New York and presented in conjunction with the Palaces of the People, Guastavino, and the Art of Structural Tile on view at the museum. It's the second in a series about the Guastavinos, and there are two more in the series still to come. On Monday, June 2nd, join Professor John Oxendorf, MIT, for another talk on the Guastavino Fireproof Construction Company. John is also the author of Guastavino Vaulting and a man who's devoted many years of his life to researching the Guastavino structures. The program will take place at the Museum of the City of New York at 1220 Fifth Avenue at 103rd Street. And on July 7th at the Center for Architecture back here, join us for a conversation about the latest innovations being forged by architects, designers, and manufacturers in the world of ceramics and tiles. Daniel Liebeskind, AIA, Ingeborg Rocker, and Matt Carlin will speak on a panel moderated by Suzanne Stevens. Now, it is my great pleasure to welcome Susan Henshaw-Jones, my good friend, the Roné Menschel Director of the Museum of the City of New York.
Good evening, everyone. You heard, I'm Susan Henshaw-Jones, and I'm the Ronay Menschel Director of the City Museum. And we, the City Museum and the AIA, have had a wonderful, wonderful collaboration over this Guastavino project. And we are thrilled to have tonight Lord Norman Foster and Roger Risdale Smith, also innovators in a long line of innovators. I want to say that beyond the AIA New York in terms of co-sponsors, our other co-sponsor is the Avery Architectural and Fine Arts Library, which is the repository of the Guastavino archives. And these were, in fact, rescued by George Collins from a dumpster in 1963. So I extend special thanks to Executive Director Rick Bell and to Lance J. Brown for being such great collaborators. And I also want to single out, we've had a group of extraordinary co-chairs for this project, and they are structural engineers Sautine C. and Les Robertson, and KPF partner Jill Lerner, who last year was the 2013 New York AIA chapter president, and KPF president Paul Katz. They all are so very responsible for making this happen. So when you see them around this evening, give them big thanks. And I have to say that Paul Katz connected us with Lord Foster, and I am so grateful for that. We're so thrilled to have you here. Now, if you have not already seen Palaces for the People, I want you to go uptown. It brings to light the work of the Guastavino Fireproof Construction Company and the father and son team of Raphael Guastavino, Sr. and Jr. Immigrating to New York City in the late 19th century, the Guastavinos brought with them an ancient building technique, thin tile vaulting, that was lightweight, load-bearing, requiring almost no maintenance, fireproof, and incredibly beautiful. What a combination. Their innovation was the mortar. And they made the vaults infinitely stronger, and they patented their system in America. As Lance was saying, I won't repeat them, their work abounds in New York City, over 250 extant major structures. And, you know, Lance mentioned St. John the Divine. That really is, upon re-examination, it's a tiled building. I mean, the crypt and the dome have no steel. It's just amazing. So there is a little booklet that we've produced, all of us, and it's a small blue booklet, and it has all of the 250 Guastavino works in New York City, and it's around here somewhere. And I hope that you will see it. Now, the work of the Guastavinos was never really acknowledged. They were publicly unknown even at the very height of their success. They worked for the best architects of the day, and who, when in drawing their plans for a structure, would simply write Guastavino with an arrow in the place where a dome was to be designed and constructed. Now, their rediscovery is thanks to John Oxendorf, the MIT engineer and professor, and he started with a book called Palaces for the People, The Art of Structural Tile. Palaces for the People actually refers to the Boston Public Library. That was their conception when they designed and completed it. Anyway, John calls himself Guastavarian, and he wants other Guastavarians to join him. And he says he'll offer lunch to anybody who can identify around the country a new Guastavino site, i.e., one that is not already identified in his book. Now, our version of John Oxendorf's show focuses on New York City and the 5 boroughs. So please come uptown. We're open every day from 10 to 6, and the exhibition runs through September. And by the way, AIA members, since we're co-sponsors, come for free. So here we are, and it's very, very thrilling in this series called Innovators to have with us Lord Foster and his engineering partner, Roger Ridsdale Smith. They've come from London. Lord Norman Foster is one of the greatest architects of our time. And he is the chairman and founder of Foster & Partners, a global studio for architecture, design, and engineering. Over the past 4 decades, his practice has pioneered a sustainable approach to architecture and ecology through a wide range of work, from urban master plans to offices, cultural buildings, and industrial design. He has been awarded architecture's highest accolades, including the Pritzker Architecture Prize. In 1999, this is so wonderful, Lord Foster. He was honored with a life peerage, becoming Lord Foster of Thames Bank. In New York City and London, Foster's work has changed our experience of the built city by imagining amazing new forms and spaces that speak to a city's densely layered historical surroundings. And I'm thinking really about the Hearst Tower on 57th Street. Roger Ridsdale Smith leads Foster & Partners' structural engineering team. In 1994, he joined Ova Arup & Partners, becoming a director of that firm in 2003. While working for Arup, he frequently collaborated with the Foster practice, including the Faustino Winery in Spain and the headquarters for Citibank and the Millennium Bridge in London. In 2011, he joined Foster & Partners to establish a creative engineering group, bringing integrated engineering design to all of the practice's projects. He also has won several prizes, and he received the Royal Academy of Engineering 2010 Silver Medal. They, Lord Foster and Mr. Smith, will discuss the connections between the work of the Guastavinos, other major innovators in the 19th century, and their own very pioneering work. And after their presentation, we're going to have a wine reception, so stick around. We invite you to that. And now I know everybody will join me in welcoming Lord Foster and Mr. Smith.
Good evening, everybody. I'd just like to congratulate and pay tribute to everybody who's made the exhibition possible. I think it's absolutely extraordinary. It's not my first introduction to Guastavino, but I think that it's done an extraordinary job in raising everybody's awareness of those achievements. Roger and I are going to do a kind of duet, and we agonized about the title, and I came up with In Praise of Anonymity, because really the Guastavinos pioneered a tradition of what I would call anonymous architecture, which for me, as I'll try and describe, is the kind of ultimate compliment. And I'll elaborate a little on that. The other title was Design Heroes. And anybody who can design a high-performance anything, whether it's a building, a car, an airship, a locomotive, and make it beautiful, deserves to be a hero. So we indulge ourselves in looking at some of the connections between these extraordinary heroes spanning several decades. I start with these images, a pair. This is the first pair, because although I wasn't aware of it at the time, when I left school at 16 and went to work in Manchester Town Hall, I was so moved by the architecture that I can remember in infinite detail the staircases, the corridors, the great spaces. That kindled an interest in architecture, although I had no idea that the profession of an architect actually existed. But I was so inspired that every lunchtime I would walk around, and it was kind of architectural pilgrimages. And again, without knowing it, there was another tradition, if you like, the classical tradition of the historical styles, the grand masonry structures. This other tradition, probably born out of a gardener called Paxton, is the metallic, anonymous, beautiful, lightweight, transparent, soaring structures. The anonymous tradition, if you like. And I think that as architects and engineers working together, we've tried to fuse these two traditions. And I'm interested in the way that these two traditions weave in and outside of each other, and the extraordinary influence of one upon the other. And if I, after Manchester Town Hall and the experience of that architecture, if I move forward to another building, which later in my teens was hugely influential. This is the local library. This is Levenshulme Lending Library. And coming out of a background where there were no books, I discovered modern architecture in this building. And if it wasn't for this building, I probably wouldn't be here talking this evening. So I have a great debt to books and to libraries and to an individual, because I discovered later, much more recently, that this building was the gift of Andrew Carnegie, who was also the prime benefactor of the New York Public Library system. So if I was enabled through this contact to go to a university and study architecture, then it's interesting as a student, 21, 22, 23, what things were I photographing then? And I was photographing the two traditions, this book, Towards a New Architecture by Le Corbusier, was one of the books that enabled me to become an architect, kindled that interest. Other books were in the nature of materials by Henry Russell Hitchcock, about the work of Frank Lloyd Wright. So eventually, when I do go to university, what buildings am I photographing? I'm photographing those buildings like this one that fuse those two traditions, the classical tradition and the liberation of space by the inheritors of that anonymous, call it what you will, functional tradition. I'm also photographing extraordinarily beautiful buildings like the Palm House by Decimus Burton and Richard Turner at Kew Gardens. And when I'm not photographing, every summer I'm drawing, I'm measuring buildings. And what buildings am I measuring? I broke the mold. Everybody at Manchester were drawing buildings like Georgian houses in the classical tradition. But I was fascinated by that anonymous tradition, by windmills, by big barns, not just what they looked like, but how they worked internally, how they were made, how a windmill functioned, and how the great barn was put together. And then later, when I left university, I discovered that I wasn't alone in terms of being so impressed and admiring those anonymous architects and engineers, because there was somebody called Bernard Rudolski who in 1964 created an exhibition at the Museum of Modern Art and produced this book. And it was called Architecture Without Architects. It could have been called Engineering Without Engineers. But it celebrated those extraordinary achievements. And in those pages, we also see the tradition which led to Guastavino, because it was centuries old and centered mainly around the Mediterranean. So these anonymous architects, engineers, builders, craftsmen were essentially responsible for the achievements that this great exhibition in the museum and the books and the scholars are celebrating today. And the fact that he was able to develop those craft-based construction methods and patent them, and then lead to the kind of works that we've been touring earlier this morning. How do we define those characteristics? Well, essentially, it's about optimization. He was able to create great spans, beautiful forms. They were fireproof. They had less mass. They did more with less. They were cheaper. In actual fact, he was competing on price. The fact that he produced something extraordinarily beautiful, which has endured over the centuries, is another great testimony. But he was just scoring on cost. And there were wonderful stories in this book on that. And he was able to build quickly. He was able to build faster than anybody else. This is a very interesting characteristic. I mentioned Paxton. Paxton did the biggest building in the world. And he did it and designed it and built it in 8 months. And it was the cheapest thing that anybody could do. Nobody could do it in twice the time, at twice the cost. So this tradition of doing more with less is, interestingly, I think, one of the prime characteristics of this anonymous theme in architecture, craft, structures, and is inextricably linked to issues in a market economy of materials and labor, the cost of materials and the cost of labor, and the way in which that might change over time has led to the birth of new technologies and the decline of other technologies. Well, here are some of our shared heroes, Roger and I. One or two of them are mentors. Others are just inspirations from the past. And Roger is going to reflect on the relationship of rising labor cost and slightly declining material cost, and the way in which they relate to a certain body of shells, shell structures.
So I want to start, or at least continue the theme of optimization by talking about shells, because they're such an extraordinary form. Just structurally, they're an amazingly efficient form. And I've put together a video, but I've got the models here, just the same models. Yes, thank you. This is just a hanging chain model. Very, very simple. Simply a series of interlocking chains which have no stiffness of their own. So they're only sagging under their own self-weight. They form the natural form that those chains with no stiffness of their own fall to under vertical load. Then if I do the same thing with a form which is held in 4 points. We have a three-dimensional form, but exactly the same thing. It's a hanging chain. And the point about this form is if we find a position for any geometry that we want to have, any corner conditions, and we solidify that chain and turn it upside down, then we have a structure which in reverse perfectly resists the same load in compression rather than tension. So I've tried to show with these models the difference between a flat plate. This is as flat as I could get it by hanging it and fixing it in resin. So this is basically a flat plate. There's no curvature here at all. And there's not very much stiffness. It'll move a lot under not very much load. That's most of the floors we stand on. Now, thanks. If I go to an arch is already much stiffer, so it's a hanging chain turned upside down, but it still only has a single curvature. So it's very stiff under a universally applied load, the actual dead load turned upside down, but it's not very stiff under an asymmetric load, the wind blowing on it, say, or the snow on one side of a structure. Then you can see this mode of deflection and, in fact, mode of vibration as well. If I go to a shell, thank you. That is, if I have double curvature, then the improvement in stiffness is exponential. It's absolutely huge. There's a massive difference in the stiffness and resistance of a shell. And that is why, just through the double curvature, and that's why shells can have a huge effect on the strength-to-weight ratio of a project, because they become so much more efficient. And as Norman says, Guastavino had continued this tradition, and I was interested in seeing where the tradition went after Guastavino, or where shells went afterwards, and also why they declined, because there was a moment when they were the optimal resolution of how to build a shell quickly and efficiently and cheaply. So back to our heroes, which was quite a competitive lineup, as you can imagine. What we found very interesting is when we looked over the period, over the 100 years, at what makes construction cost. Construction cost is made of materials and labor. Those are the two ingredients. A little bit of direct energy, that is the energy of what powers the machines on site, but mainly the materials to make something and the labor to build it, us, people. And what's really interesting is that materials have got pretty much constant or slightly cheaper, and of course labor, that is how much people earn, has quite understandably got far, far higher. And I was interested in why that was. Why would that be? Why would you imagine that? Would you imagine that materials would get cheaper but labor would get much, much more expensive? And the reason, and the hypothesis I have, but after quite a lot of research into the area, is energy. Everything comes down to energy. The cost of a material which doesn't have a scarcity value, which doesn't have a brand, so not gold, not diamonds, not Gucci handbags, is pretty much directly related to the energy used to make it. So here is a graph. Here's a graph of the price of a material compared to the embodied energy of its creation. And so expensive materials are the ones which used a very high temperature process, so metals. And cheap materials are ones which you basically dig out of the ground. So aggregates. Timber is, the cost of timber more or less is the cost to transport it. Then you have sort of rarity values, but that's where timber, low-grade timber starts. So if oil prices, basically energy prices, have stayed constant, we can see why material prices have stayed constant. Then when we move on to labor, why would that not apply? Well, labor basically is the amount of energy we consume. The amount of energy that society has consumed is very, very closely related to the amount of the GDP, the gross domestic product of our economies. So I found that really interesting, and I found it really interesting to see where that took us, and sort of to investigate where that took our design heroes, because the first design hero that Norman and I agreed on very quickly was Eladio Diesti. Eladio Diesti is absolutely extraordinary as a shell builder, and he lived in Uruguay, and Uruguay have kept quite a low cost of labor. That is, if you see along the bottom, the cost of what people were paid to build buildings stayed very low, and that meant they could keep a labor-intensive process like tiled vaults, and that's what Eladio Diesti designed. And they're absolutely beautiful. They're breathtaking. This is a 50-meter span, and it is a single layer of brick in a curve, but a single layer of brick, and not even in its depth. It's actually in the thin edge of the brick, and that goes in a curve, and that makes this. And these are all industrial buildings. They're grain silos and port warehouses in Uruguay. This is a building that Diesti won a competition to refurbish. He kept the walls, all of the other entrants knocked the walls down. He kept them and built a new roof with, once again, this single layer of brick. So a labor-intensive process, but one that he could carry out, as well as being an absolutely extraordinary designer. This is the internal view of that. So also sort of beautiful effect. And there's a grain storage silo. So again, a double curved, he's brought double curvature into a barrel vault, and that's what gives it the stiffness. That's what stops it from buckling. And this is a final one where we just couldn't resist putting this one into basically a church in Uruguay as well.
Stunning.
Yeah. So on to another place which also kept a low labor cost, and that was Cuba, and still is Cuba, in fact, because of course the environment was that everybody should be employed and that labor costs would stay low. I have a theory that Che Guevara in this photograph is pretending not to be able to play golf, because I think he was quite good at golf. But what happened was Che Guevara and Fidel Castro agreed that the Havana Golf Club should be converted to a series of schools of dance and culture and arts for the people. And one of the projects was a project that we've had some involvement with. We've carried out a feasibility study to see whether it could be reused. Absolutely beautiful school of dance in Havana, just outside Havana, built in 1961, completely unmaintained, sometimes even a little bit of badly treated, floods, hurricanes, weeds going through, and yet still these structures survive, and they're once again built as tiled shells in just the same way as the tiled vaults have always been built. Oh, I'm sorry. Absolutely beautiful interiors, but once again achieving double curvature. So then I move on. Then I say, well, okay, so that was areas where there was a low labor cost. What about the rest of the world, Europe and the United States? And of course the story there is different. Labor's become far more expensive, so much so that in 1954, a Guastavino shell, because they were just beginning to, well, they were pretty much finished, but they were just beginning to think about winding up, cost twice as much as a concrete shell. And the concrete shells really came from Europe, Germany in particular. But the first of the heroes that we wanted to show was Pierluigi Nervi, who he solved the problem of buckling in a shell, which is the big challenge of concrete shells, by having these stiffeners, which were cast into the concrete. So he used extremely thin concrete, 4 centimeters thick concrete. This is the Palazzo de Sport in Rome, to make these absolutely beautiful structures. And he was very conscious of that. He was aware of the beauty of what he was doing. That was his concern. And then to Germany. Germany was really where a lot of these shells came. There's quite a lot of load tests that were carried out like this, which you just think you'd really want to maybe put a sandbag there or something first. So what happened in Germany, which I found absolutely fascinating, and in fact through this process learned more. I knew about the shells, but I didn't know about the history, is a company called Dijkhoff and Widman, actually started simply making things out of concrete. They didn't start to make shells. They just thought concrete was an interesting material at the turn of the century to make things. And they made statues and concrete pipes. And then in their later generations, around about the 20s, they thought that it would be an interesting material to go a very long way. This shell is extremely thin, a couple of centimeters thick, but has exactly the right curvature. And they were trying to learn about the behavior of concrete. Of course, concrete does different things over time. It doesn't stay the same over time. It creeps, and that's one of the things that dramatically changed concrete design through this century. This is a market hall in Leipzig, which was one of their first big, thin shell projects. That was in the 20s. And there it is finished. And what they also did is there was a fashion for planetariums at the time. And Carl Zeiss, of Zeiss Photography, had a business in making planetariums. And he needed somebody to make good enough quality shells that he could have a focused image on his domed roof and a thin enough dome. So what they did is they made a frame of reinforcement, a cage, which they then sprayed concrete onto. So these workers are actually standing on a single layer cage of reinforcement. Once again, load test, interesting load test procedure. But that was the way that they made these planetariums. And then from there, they took their shell technology to the States, and that was in the 30s with an engineer called Anton Tedesco, and again a design hero of ours, and an extraordinary man who took this technology, and really that was the moment that Guastavino really started to face very stiff competition, and they were sort of aware of it, but they didn't. You could see that they hadn't completely hoisted on just how serious a competition it was. This is the planetarium that was built and sadly knocked down in 1997. But this is the Hershey Stadium, which is still existing and spans 70 meters. It's a barrel vault with ribs and is only 3.5 inches thick in the middle. Here's the most extraordinary photograph of it being built. It was built by Hershey's employees. That was what Milton Hershey decided should happen. So they are those are the people who normally work in the chocolate factory, building their own stadium. And there's the finished shell. So once again, extraordinary that a new technology came in as a result of optimization for different constraints, that instead of labor being plentiful and not too expensive, labor became more expensive, and so a process involving less labor was a more optimized response to that. The final of our heroes that I wanted to talk about as a shell maker, and really the person I think who took shells to a whole other place, is Heinz Eisler from Switzerland. And he took these very basic hanging chain models I was showing you and actually set them out and measured them. So he spent a lot of time taking, this was all obviously before computers, taking shapes, hanging them, and then measuring them and building them, which just seems incredible. He also took pneumatic structures. He basically put air into a rubber surface and measured the surface that he got as a result, and once again built it. So this is the paper that he submitted in 1950 for the first conference of shell structures, and it blew everybody away apparently. What I really like is the fact he put etc. at the bottom. And sort of just an unlimited number of different forms could be created with double curvature. The whole point being there must be double curvature. This is this is one of his most extraordinary structures. Once again, just for a company, for the Sickley company in Switzerland. He did know about buckling, by the way. He wasn't these things weren't done innocently. He did some quite impressive calculations to decide whether or not they could be achieved. Most of his work was done in Switzerland. He wanted very, very close supervision of them. Here's another one in Regensmill in Switzerland. And then finally, I consider the most extraordinary structure, once again in Switzerland, exactly the same thing, taking a form, turning it upside down and setting it, measuring it, and then building that structure. The other thing he did, which I find incredible, is he would, in order to demonstrate this to himself and to others, he'd take blankets and he'd put them into his garden and spray them in water in the winter, and they would freeze, and he'd turn them upside down. And here's one of the examples of that.
I think that there are many ways in which we can find forms, and in one sense, these are the forces of nature, gravity, acting, frozen, coming from a somewhat different direction. Buckminster Fuller, somebody that I was privileged to work with, collaborate with over the last 12 years of his life, was inspired by nature. And I can't remember any conversation with him where he didn't relate and demonstrate an affinity with the natural world, with spiders' webs, with shells, with plants. But his forms, driven by a more mathematical approach and the exploration of the tetrahedron and spherical geometries, of course, delivered structures like this, which become synonymous with his name, and geodesic structures, tensegrity, a whole range of words to describe these extraordinary, elegant constructions. If I had a second bite at this talk, I probably would move to an image of the radomes being transported by the American Air Force by helicopter to remote locations. Because again, a bit like Paxton and like some of our heroes that Rogers described, these guys were making things which were lighter, more transportable, and a fraction of the cost of the competition. So that competitive edge, notwithstanding that they were also wonderfully in the beauty department as well. There's another aspect of Fuller's pioneering abilities, and one is the Dymaxion car, which has been quite inspirational at a personal level for me. The Fly's Eye Dome, which I worked on with him in the 1970s with an individual called John Warren. And the teardrop form of the Dymaxion car, which by virtue of its streamlined shape was able, with the standard Ford components, to be able to carry more people significantly faster at lower fuel consumption, again was an automotive embodiment of his philosophy and his ideals. Whether or not he was aware of it, I don't know, because we never talked about that, but that would have been impossible without the pioneering work of Paul Jaret, who was really the father of streamlining. And as a result of this, and we could spend a whole evening just talking about this shape, why it's that shape, and why it's so beautiful, and why it's so efficient, and why in a way it heralds in a new streamlined age, which we live with and which we take for granted. So another way of forming forms, but again working with nature in a different way. The wind tunnel, the bodies that will move through air. And very interesting, this was the basis of his patent in 1921 for the first streamlined car. And it has interesting echoes in terms of the art of the time. As early as 1913, Boccioni was anticipating the wind tunnel in his flowing forms, and Brancusi's Fish has remarkable overtones of Paul Jaret, the engineer working in a wind tunnel. And Paul Duret was also the early pioneer before he went on to design cars such as the Tatra. He was the pioneer of airships, along with another individual who I'll come to. And this is the Hindenburg, again, coincidentally, in 1921. And if you look at some of these forms and shapes, the very, very beautiful Zeppelin suspended in the hangar, the other one coming in, these were extraordinary creations. In parallel, somebody who was also exploring geodesic structures, somebody called Barnes in Britain, who produced in parallel the R-100 airship. Again, extraordinarily beautiful, lightweight, high-performance structures, which he then took further in one of the very, very few, almost indestructible bombers of World War II, which is the Vickers Wellington. And so here you can see the geodesic structure. And I often wondered whether Barnes Wallis, who was the creator of these aircraft and airships and geodesic structures, and Bucky had ever really overlapped in their lives, because they were both in parallel of the same generation, exploring the same high-performance, lightweight structures. Again, very much in the tradition of Guastavino. And coming back to the hero Paxton, if we look at one view of his Crystal Palace of 1851, you can see that actually it was very dependent on triangulation, was almost an early version of a sort of geodesic arch structure. And another pioneer, the other side of the world, was also exploring extraordinarily beautiful forms in terms of here, transmission masts in the 1920s in Moscow. And this is Vladimir Zukov. And perhaps the most famous, and it's had a kind of searchlight on it in recent times, is the radio mast in Moscow. And again, that very beautiful triangulated structure, sadly in a state of some disrepair, because it's untreated, the steel, and is subject to corrosion. And because of its unique qualities, absolutely one-off, one of a kind, and beautiful on the skyline, and an important piece of historic heritage, I led a campaign for its preservation some time back. And that issue of unprotected structures and the tradition of the anonymous engineering mainstream weaving in and out of the classical architectural mainstream. Possibly one of the best examples I can think of is the New York Public Library, because from the outside and from most of the inside, let me put it this way, all of the inside that you can see, with one possible exception in the Bartos Forum, is of this wonderful, classical, beautiful, incredible vaults, beautifully crafted, and a building which we as a team, and me as an individual, has got to know very absolutely extraordinary work of architecture. And whether that is in the public circulation spaces, or whether it's in the Rose Reading Room, surely one of the greatest spaces of all time, whether a library or not, is interestingly held aloft. Its very existence is literally based on the anonymous structure, engineered, holding it up, which is this vast repository, huge space, bigger than the Rose Reading Room, because the floors here are not structural. And that system, with its grid of 9 foot, 7.5 inches, has determined everything in that building. Every corridor, every stair, every wall, Every window opening, inside or out, is driven by that grid on plan. And what is more, the height of every room is driven by the 7'6" module of that storage system. So if we look at literally the cross-section of that space, which is here, the 7 modules, you can see how the 7 modules is replicated in the Rose Reading Room, which it holds aloft. And in the modules of all the secondary spaces, the circulation spaces, the study areas adjacent to it. And if we move into that, something has gone strange here. Well, what you should see, I'm going to have to paint a picture for you. You should see the stacks. Ah, fine. Okay. And as you can see, the stacks are on that module. So that is the module in that direction, and that is the module in the other direction, which is driving the geometry, the setting out, the architecture of this incredible, splendid building. You will notice that the stacks are now empty, and they're always going to be empty, because it was always, well, not always, it was for a long time decided that the books would have to move, because otherwise the Rose Reading Room sits on top of an unprotected structure. So you cannot have combustible materials. Now, that decision was, the first move in that direction was in the last century. And that move, you can see the start of it here. It was the opportunity for the library to vacate the stacks and to create safe, with up to present day standards of preservation for rare books for the research library, to put those in appropriately protected space on site with a volume, exactly the same volume as the stack storage area, to house the between 3 and 4 million volumes of books. And if you were to go there and see where those are on site, they're in this part of the 2-story building. The other story is going to be converted, or rather fitted out, excuse me, so that it has, it looks like this. So if we look at the plan, and you can see, I don't have a pointer, so it's up here. That is the stack area, which is holding up the Rose Reading Room. And the engineers on the project had assumed, everybody else, I mean, everybody had assumed for years that the stacks would come out, and that would be the opportunity to bring back the circulating library, where it had always been up till 1985, back into the building. So, not surprisingly, they envisaged it as the most economic solution would be to put a structure, columns, within the body of the space. And then what happened is that there was a reaction against taking out the stacks. So at that point, we stopped in our tracks, and I got Roger, and I had everything that had been designed on the project with the structure and the columns in the space. And I said to Roger, the New York Public Library, it's all pinned up here. There were just the two of us, and this was in the office. This was a little while back. What would happen if we wanted to keep the stacks? Some of them, all of them, and you can't put a structure in the space. And Roger said, I don't know anything about the New York Public Library. I mean, you know, so I said, well, immerse yourself in it, give yourself a day or so, and see if you can work miracles. And extraordinarily, and it's better actually if Roger explained this himself, but I'll do it on just for convenience. What happened is that Roger discovered that all the windows onto Bryant Park had these kind of structural pilaster walls. But every third one, and that on the top there, you can see every third one, there's a red blob. Every third one had a tin duct. And Roger worked out that you could insert a structure that would carry a beam above within that space. And at that particular point, you had total freedom over the stacks. And what's more, he reckoned that it was such a simple solution that it would be more economical. And so that was tested, and Roger flew over, got together with the engineers who were assigned to the project. They had a fantastic relationship, and everybody loved the idea. So the idea took root. And so we can see now where such an idea could lead. This is a model, and it shows the stacks as they are now, supporting the Rose Reading Room. And by this very discreet, highly economical, very elegant solution of inserting in the walls, then beams can span under the reading room. The reading room is protected for all time against fire, and the structure is combined with a distribution system for air and filtration. So if it's filled with books or half filled with books, because the stacks can go back exactly where they are. In actual fact, some of them don't even need to move at all. You just need to take the floors out or leave them in. So you, at that point, have complete freedom. What is also very nice is that this new lending library, circulating library, can have its own dedicated entrance off 42nd Street. And there's a very nice coincidence here, because when the library opened in 1911, this is what the entrance, it's now called the Bartos Forum, looked like. That was the original circulating library off 42nd Street with its own dedicated entrance, which also served a children's library, which was also the intention to bring back. So, but also you could access this space from Gottesman's Hall. So if you go through the existing opening there in Gottesman's Hall, then you would come into the entrance area, you would descend on the staircase to the right, you would come into a new reading room, and with the opportunity, this is still a study, so it's not definitive in terms of the colors and the textures and so on. But what you do see is you get this great view into Bryant Park. It's filled with natural light, and working with the artist Jamie Carpenter, who came up with the concept of lining the reveals to these deep, tall, generous windows with a slightly polished steel, not mirror-like, but would start to introduce the glow of the greenery and more of the sky into the space. And if you look behind the stacks there, then you would see a variety of spaces for specialist libraries and so on. It's interesting that the author, or rather the manufacturer of the stacks, Sneed, his description of how he saw the library in the future, that it would be inclusive and it would be about the celebration of books for research and also for lending. So if we look at that space and its relationship to Bryant Park, then it's very easy to start to see the potential, which we also explored, and were able to demonstrate that you could make the lending library, the circulating library, permeable and accessible from Bryant Park. And I think it's an interesting, if you like, balance, a value judgment between, on the one hand, the potential of this space in this location with this generosity of windows and natural light, its relationship to the park and its social possibilities as well as its architectural possibilities. And if you balance that against the prospect of forever to come, you have this tomb of stacks. Now, unlike Zukov, which is one-off and unique, these stacks were produced over many years, and every state in the United States, out to the Philippines, Hawaii, has Sneed stacks. They're a catalogue item. They're in the Vatican. They're in Greece, Italy, France. They're in India, Japan, China. So I think it's an interesting balance. There are all kinds of parallels, interestingly, between Sneed and Guastavino, because they both essentially went out of business within a decade of each other for the same kind of reasons. Not exactly the same reasons, but overtaken by competitors. For example, Sneed, in the end, unlike Guastavino, couldn't be fireproof. And it's interesting to see the relationship of fire to architecture, to pioneering, whether it's the Hindenburg disaster, which was the end of the lighter than air transportation, whether it's the Great Chicago Fire of 1871 that essentially gave rise to the high-rise building, which was very much about fireproofing, but was also emblematic, I think, of the modern age in terms of the cantilever. And it's interesting that out of some of these more anonymous developments of frames and elevators, that the celebration of the tower as a vertical cantilever, this is the Empire State Building being tested against horizontal wind loads in a wind tunnel and producing these emblematic vertical cantilevers, which interestingly were in parallel with horizontal cantilevers. And the way in which these weave together and overlap, the cantilever horizontal chair, and the transformation with the technology of aircraft, which were almost, let's skip one, should have been there, which were like flying bridges, trust, and the expression of the cantilever in this extraordinary photograph by one of my favorite photographers, the Life magazine photographer Margaret Wright, excuse me. And in the background, the vertical cantilever of the Empire State Building, a wonderful juxtaposition. And for me, the image under one of my favorite heroic cantilevers, Tempelhof Airport of 1935, roughly the same vintage as the DC-3 in the foreground. It's skipping, but I think maybe it...
Just use the arrow.
Okay. And Frank Lloyd Wright, again, in this period of the 30s, the celebration of the cantilever. And another hero that Roger mentioned, Candela, and again, the celebration of the cantilever. Another of my heroes, Conrad Waxman, who I met when he was teaching at Los Angeles, and again, the heroic cantilever. And on a more domestic scale, the wonderful house of Pierre Koenig, the case study house overlooking the skyline here of Los Angeles. And I mentioned Paxton and his pioneering work. And in the next image, in one of his gardens, he's musing on the ability of natural forms, the giant water lily, to be able to support his 12-year-old daughter. And in that wonderful tradition of natural forms and this amazing gardener, intuitive engineer, architect, I often wonder about whether there's any relationship between those lily pads touching and Frank Lloyd Wright's extraordinary lily pads which touch, and a series of individual cantilevers. And I enjoy the image of Frank Lloyd Wright in the sort of bottom right there, demonstrating to a skeptical local building superintendent the virtues and possibilities of his structure. There's a whole series where it eventually gets so loaded up that it kind of collapses. And Frank Lloyd Wright also, one of his favorite objects is one of my favorite objects, and that is the Gullwing Mercedes 300 SL. And interestingly, that fits into my anonymous design tradition, because unlike Harley Earl or Pininfarina, this car didn't have a kind of name designer, but it has the most stunningly beautiful lines. And of course, the Gullwing doors are absolutely unforgettable. But what I'm sure many of you know is that the Gullwing wasn't some kind of whimsy of a designer, like let's have some kind of trendy new door. It was born out of the fact that this car was designed to win races, and the only way they could improve its performance was to make it lighter. So in that tradition of anonymous designers like Guastavino, the only way they could do it was to make the structure close to a monocoque and deep and thin tubes. That's where they would save the weight. That's how they would go faster, which meant that the whole depth of that sill was structure. So you couldn't have a conventional door. So the Gullwing was a response to that problem. Inside, I mean, the structure is truly beautiful, so beautiful that there are artists who make 300 SL chassis and sell them to kind of nuts like myself. I've always admired those kinds of structures, again, engineered for the maximum performance at the minimum cost. And again, as a student traveling across the States and the Midwest, I'd be stopped in my tracks by some of these, and I have a whole collection of anonymous structures. And these, of course, they go round in big circles and they irrigate. And recently, another hero, we were in his studio, a guy called Edie Burtynsky, based in Toronto, a photographer. And he produces images which are like the most stunning paintings you've ever seen. And this image taken from above, I think is, you know, just one of the most beautiful images ever. So as we go away from Earth and out to space and end up somehow, inspired by Guastavino, on the moon, what are the stepping stones to get there? Well, it's a structure that we did in the 1970s. It's an air-supported office, and this was for a fledgling computer startup. And we housed them in a factory, and then they wanted a new building. And the problem was, how did they carry on? Because the factory had to be demolished. And we came up with something which I think at the time had a budget of 75 cents a square foot. And we designed this air-supported office. And that's what it was like on the outside. And on the inside, this is what it was like. And the light fittings were designed to respond to the concern by the authorities. What would happen if the pumps that drove and supported this with the air pressure, what would happen if they failed? They couldn't accept the idea that it would sag very, very slowly and allow everybody to get out. So in the end, to convince them, we designed these poles of light fittings so that if it deflated, then it would just kind of hang sagging on the poles. That's one ingredient of our kind of flight to the moon. The other ingredient are the studies that a specialist group, a research group within the practice, which feeds into projects and also works on its own projects as well, into bone structures in nature. How do you make a cellular structure which is immensely strong? And that was done in the office. And then, because the challenge of building on the moon is that you cannot transport much material, so you have to use the material which exists on the moon, which is dust. It's everywhere, and it's called regolith. And the closest you can get to moon dust on Earth is in a volcano, volcanic ash. So part of the feasibility study for the project was to check whether we could use the three-dimensional printing process robotically controlled, and whether that was truly feasible. And this demonstrated its feasibility. I should add that we are one of three entities acting at the invitation of the European Space Agency. One group is based in Holland, and the other group is based in Italy. And because of our pioneering work in three-dimensional modeling and engineering abilities, then we were invited to be part of that consortium. And we've worked with the astronauts and with the various engineers. And there's a small film which talks a little about the project and shows how that might work in reality. Not might, can work, that we've demonstrated. So you have the challenge of transporting the lightest, smallest amount of material and machinery that can be robotically controlled in an environment which goes at a high of boiling point, 212 degrees Fahrenheit, and at its coldest is minus 270 degrees. And then another challenge is if this structure gets damaged, and what are the hazards? The hazards are meteorites, great rocks traveling at faster than the speed of a bullet. So how do you design a structure that can absorb those kind of shocks, withstand that, create enough dense insulation also to control the temperature. And this simulation explores how, by sending out machinery, by using the local material, combining that with the minimum amount of binder as glue. And here you can very clearly see that cellular structure. Remember, the cellular structure has been made out of that combination of moon dust and the binder. But the holes are just filled with the dust, which acts as a cushion against meteorites, provides the insulation, and again determines the form. So I think that this is probably pushing the idea of an anonymous architecture, very much in the tradition of creating three-dimensional forms and vaults in an extreme environment. And the elements which contain the inflatables also are reused as the entrance locks. So everything has a double use. It's not just a piece of kit for transportation which is then abandoned. So, thank you very much.
Well, thank you very much. I think that's an illustration of taking an idea full circle. No pun intended, but well done. I think we have a few minutes for folks out there who might like to take advantage of this time to ask either of these gentlemen a question or two. We have people with microphones, so for those of you who raise a hand, we'll try and get a microphone to you.
I was in Abu Dhabi and I saw the mall that you have designed with the two towers. And frankly, I was very impressed. I thought that how come you as a person, British person, can design such a mall as if you have lived all your life there? The details, the doors, the space, even the graphics. How the research was done? Thank you.
The way in which we would research any project with local collaborators as a team. You don't have to like it.
Did you say impressed?
Oh, I'm sorry, I thought you said you...
You were impressed.
He was impressed.
I didn't hear that.
No, he was impressed.
I didn't get that first either.
Sorry.
You know, if I could, yeah. If I could, it's a very interesting question, and it's one that's raised quite
I'll go out
often.
and come in again.
Yeah. This is a question that's raised quite often in architectural circles, certainly in academic circles.
In which case, I can answer your question a little more sensibly. Oh, I'm not you. I thought I was wired up.
You're wired up.
Can you hear me? Okay. What happened was that the project came in and they wanted a mall. And I said something like, oh my God, you go into a mall, it could be anywhere. You could be, you know, in Abu Dhabi, you could be in Manchester, Toronto, you could just be anywhere in the world. And I'd again, in the spirit of anonymous architecture, I'd got a lot of images of souks. One particular one that impressed me greatly in Marrakesh. And so I said, couldn't this be an opportunity to encourage local crafts which are in decline? And couldn't it learn from the lessons of the traditional souk, which is filtered light? And interestingly, I tried to discover the outside elevations of a souk in Marrakesh and couldn't. It was really anonymous. I mean, it was buried between buildings, had no elevations, but magic interiors, full of mystery. And I managed to get the case across to one of the sheikhs who was visiting, and I explained this idea, and he was supportive. And that was the genesis of it. Also, in terms of the patterns, which were eventually cast using desert sand, which, interestingly, you always have dust, even in Abu Dhabi. And so these cast forms, and we worked with a French artist who studied the mathematics, the geometry underlying many of the Islamic Moorish patterns. So we worked with him. And the problem with buildings there is that they always have this thin layer of dust. And interestingly, it never looks dirty because it's always dusty. So it fits in very well. Thank you.
Over here.
Hi, I had a quick question about two residential buildings you're working on in New York, if that's not too off topic. Both your West Chelsea project on 21st Street and 50 UN Plaza have these completely insane penthouses that are ridiculous with enormous pools. And I was wondering how you incorporate that idea when you're designing residential buildings, specifically in New York, if you can answer that.
You know, the wonderful thing about the world is that there are still differences between places, and places, different places seem to generate different kinds of spaces. I think on those buildings we're working with very sympathetic developers who are seeking to push the boundaries, to push standards, and respond to local needs. And so again, different forces behind different projects, and I think it's a reflection of the fact that New York is such an extraordinary phenomenon. You know, it's just great being here. There's incredible energy, and it's on the move.
Other questions? Yes.
Would you say that the people pushing back about the New York Public Library has resulted in a better design because you discovered all of those new structural elements?
I would say that that when the brief changes, then you have a choice. You can push on, or you can use it as an opportunity to reinvestigate and to see to what extent you can push the boundaries to do something which performs even better. And so I think that those changes, whatever direction they come from, are progressive changes, mindful of the fact that all the great initiatives in any and every city have always come out of the courage to answer the need, to make the statement.
Yes.
I I find it so curious that your design heroes are anonymous architects, and yet you yourself are such a superstar. I was wondering if you had anything to say about the status of these superstar architects, or.
I think that somebody asked me in a similar kind of venue about buildings and like, what's your favorite building? What do you think is the most influential building? And this was centered on London. And I said something along the lines that as an architect, I'm obviously passionate about architecture and designing buildings. Otherwise, I wouldn't be an architect. And it's, it's the stuff of my life. And I'm passionate about it. But I think that infrastructure, the urban glue that binds the buildings together, is more important than any individual building. So if I think about London, I think probably Trafalgar Square, which looks deceptively simple, but if you see a film of it now, and as it was before, it's a total transformation. And that was by making a number of small but critical changes and closing one road. And that transformed the very heart. And people could never imagine going back to it as it was, which was a very, very dangerous roundabout with a kind of isolated island. Now it's connected. It's part of the pedestrian realm. And the other initiative that I cited is the one that we worked on together some time back, which is the Millennium Bridge, and the way in which that connects a pedestrian route on the axis of St. Paul's, and the way that that has totally revitalized the area. We did a lot using a research group, which we've since developed within the practice, to chart connectivity in terms of pedestrian movements and the way that that can change the very nature of neighborhoods, because traditionally the North Bank has always been the prosperous bank, and the South Bank has always been, in terms of the city, it was the brothels, and so there's always been this resistance to make the connection, and making that connection was truly phenomenal. Now, I think and that bridge, as a bridge, all the energy that went into it was to make it almost disappear, the blade of light. So it's a suspension bridge. It's the only suspension bridge in the world where you really have to look very, very hard to find the elements which suspend it. They both are the ultimate in anonymity. That's my answer to your question.
Bravo for that answer. Bravo.
In the digital age, how do you foresee libraries going forward, and how do you think architecture will actually address the issue of, say, from text and physical books, we're moving into reading more digitally? So how do you foresee architecture taking that experience from books into, say, handhelds or other materials?
It's an interesting question. Not that long ago, there was... Why don't I switch this off? Yes. It's on mute. And see whether that works.
Much better.
Okay. Some years ago, there were congresses and debates about the paperless office. There have been congresses and debates about whether the workplace needed to exist anymore, because we can all work from home. And the technology enables us to do that. And I find it fascinating that, again, as we invested as a studio more and more in the digital world and computers, people were saying, and we won't need a model shop anymore. And why is it that we've got more space now in model shops? And I'll give you one kind of insight into why. because we have huge spaces for model shop. We're doing full-size models as well as tiny models. We go to Silicon Valley and we present, and we fill a space probably about 10 times the size of this space here with models. So in the heartland of the digital world, the means of communication are by models, and some of those you can walk in, inhabit, and others you peer in. It's also fascinating that in this digital world, statistically, here in New York, the demand for lending libraries, circulating libraries, is on the increase. So I think it's we were talking earlier about the future of drawing and whether people will still draw. And somebody was saying there are only 2 schools of architecture in America which actually actively teach drawing as a skill. I think there are going to be paradoxes. I think that as the world becomes more virtual, there will be the parallel need for people to come together more. I mean, the Congress and conference circuit has never been as active. It's a massive growth industry. It should have evaporated in the digital world. It hasn't. So I think that the more remote we have of experiencing without human contact, the paradox will be that we will desire it more. But that's personal.
There are a couple of questions all the way in the back. I don't know if everyone heard that, but basically the question was, does Mr. Smith see a resurgence in the use of thin skin shells?
We're just debating it between us.
Shop talk, perfect.
Roger should really answer this as an engineer, but I just reflect that in those economies which are emerging, for example, we've done a pilot project on a charitable basis for a school system in Sierra Leone, and there the onus is on a construction method that will really harness the services of the community, a bit in a way like Hershey's building their own sports stadium. So I think that there is tremendous potential for the lessons of Guastavino and high performance, high labor intensive structures in those economies where the labor costs are not only low, but there is a social imperative really to bring people together to create their own environments. That, I think, is just a great possibility.
Well, I agree, and I think there's another direction that we're going in. There's a sort of another side to material prices, which is they're going up because energy is now getting more expensive, and the scenarios are changing. So I think material efficient structures. Norman talked about space frames. That's a whole other fascinating area of using simply made, rapidly made structures, metallic structures like Buckminster Fuller, once again, I think there's a whole world of that, and I see no reason why those structures shouldn't be used more and more. To some extent, there is definitely an evolving world of those structures too.
There was another question in the back, and there's one in the middle. If in the back you want to yell,
Can I jump in real quick?
We can't hear you. You would have to yell.
I was wondering if you could share a little bit about how your work and research on structures and shells, how that is relevant, or if you've expanded on that with your work on the Apple headquarters, with working with glass and like that design there.
Yes. So we are doing a lot of research into new materials, into both different materials and different structures. So you've cited Apple. That does have some extraordinary technology, material technology. It's also going to be an interesting structure because it's in a region, obviously, which is seismic, and our response to that is particular and new. We are using shell structures on some of our new designs, and we are going to carry out some research on those as well. Actually, in another direction, there really is, there are lots of different directions that research can go in. One of the other directions that we're looking into at the moment is timber, the efficient use of timber. I mean, obviously, timber is something which is either extremely environmentally responsible or the opposite. You're either using timber, which is a renewable resource, and if it's properly harvested, it's actually a really excellent way of a country making money, or obviously it's depleting a resource which is finite. So we're looking at ways of using timber in more efficient ways than it has been at the moment, and that will inevitably involve testing, because some of the ways you use code design inevitably involves assumptions that if you could get past them through testing, you could push the limits of your structures further. So a whole series of different ways at the moment.
I think
in actual fact, in one of the homes that we occupy, we've rediscovered traditional cladding materials like timber tiles, and that is environmentally very responsible, because you do have a culling of timber, of larchwood in Switzerland, and so effectively we're recycling something like that. Then it has no maintenance implication. It just changes color according to its exposure to rain. We don't know its life. We reckon it's going to be at least 100 years. Now, it doesn't need any treatment. It doesn't need any painting. Again, that's good news in terms of sustainability, and it's insulating as well. So it's reusing a combination of techniques for timber, because the whole structure is prefabricated. It was essentially driven on a truck from a plant in Germany, and was driven directly by computer from the office, the cutting. So an interesting mix of technologies.
We have a question from the left. I left that to anyone's interpretation. We'll see what the question is.
I'm just going to go for it this time. I want to ask about 3D printing. It's such gee-golly technology, especially when you do it on the moon. But we're seeing it here on Earth, too. China was recently in headlines for 3D printing entire houses in not very much time at all. How do you think 3D printing is going to change architecture? And is it something that is going to transform the way we build cities, or is it something that's just noteworthy because it's so new?
Well, it's certainly having a transformative effect in the way that we explore designs. I mean, the fact that we can design something, leave at the end of the day, put it in a machine, and the following morning we've got a 3D printout is
tremendously exciting. I think you're right. I mean, I think that that in a way, the project that I've shown for the moon is an extreme example. In relative terms, to print a building now in the more benign environment of our planet is not a big leap. And as you say, we're already seeing those signs. So I think that yes, it will have a transformative effect. In the same way that the technology for driverless cars, there'll be pilotless aircraft. Maybe we'll need the psychological reassurance of somebody sitting up there and looking at the robot just to make sure that it behaves itself. But otherwise, never let any one of us near those machines because we're lethal, we're human, we're imperfect, we make mistakes.
There's one there, and then we'll come to the front.
Hi, thank you very much for your lecture. Can you please, I assume that your research in shells directed also your design in Reichstag Dome. Can you please describe how difficult it was to incorporate a new structure in a old damaged building and design a more sustainable space? Thank you.
I can try and give you a few insights into that. There were two competitions, and what was going to be a one-stage competition became a two-stage competition. And so in the final countdown, we were given an opportunity to present. And we presented, I think it must have been about a committee of between 30 and 40 people. And behind each one, there was another advisor. And at one point, we said, do you know how much it costs to run your house? And they all looked at each other. And they said, what do you mean by house? So we said, well, this is your home, isn't it? Parliament. And they all looked at each other, and they all talked to their advisors, and they hadn't a clue. And we told them how much it cost, and how much, and the fact that they were, in Germany, at the cutting edge of the debate on green issues, and that certainly, as a cultural climate, very, very advanced, probably more advanced than anywhere in the world, in terms of its encouragement and public debate on such issues. So we said they had an opportunity to use the building as a demonstration that it could be zero waste, zero energy, that it could be entirely run without fossil fuels. And that prevailed, and I think it was a factor, finally, of why we were chosen for the project. I don't think it was the only reason. And then, later in the process, we developed the Ecological Agenda with a series of initiatives of directing light deep into the heart of the building to reduce the dependence on artificial light consumption of electricity, reducing the heat loads, and a whole array of all of this then coalesced into an opportunity to create a viewing platform and make the roof a public space. That, like the ecological argument, had never been part of the original brief. And despite the dissenting view of minority of the committee who said, why would anybody ever want to go on the roof of the Reichstag? And then we proposed a restaurant. And some people said, but why would anybody want to go even up there for a cup of tea? So when it opened, and it was flooded with people, and there was a press conference, and one journalist said, Mr. Foster, I think you've been very negligent on this project. The restaurant's not big enough. So I think that as the project evolved, it found favor, the ideas, and there was a courage to do it. I mean, there was a very, very strong leader, a lady, Rita Zusmut, and they just worked at it. And they took a lot of criticism, and finally, when it was completed, they took a lot of praise.
We have time for one more quick question, and that will be yours.
Do you foresee a large-scale colonization on the moon using 3D printing, or do you think that logistically it's not possible?
Logistically, it's eminently possible, and we've demonstrated that. I think that the kind of the desire to climb mountains because they're there, and do tall buildings because you can do them, and fly off and defy gravity, makes no sense at all. And yet, it drives society. And because it's there, there'll be enough people who want to go. Large-scale colonization in that environment, I don't really see it. I think I'd rather be down here. But I'd love to try it.
Well, it's a good closing comment or question for a couple of reasons. One, I think, I realize more now, having heard you speak this evening, why, in a way, we kind of love you. Because a question like that will get an answer. Some people won't entertain it. There's just an ethical sense of expansion which has kept your practice always at the forefront. You're not repeating what you've done. You're looking for what you haven't done. It requires enormous amount of research. It's enormously optimistic. It dealt in advance with many of the issues that we're confronting today. I was just thinking that in Hong Kong, you could have broke the glass ceiling of architecture, if you know what I mean. I mean, a world of puns. You come up into the bank through a glass ceiling on an escalator, you broke the glass ceiling, and then, you did it again in Berlin by covering the ceiling you broke. I mean, the whole business, your Bruno Taut, adventures into the universe are really legion. It's very, very wonderful. It's not so much an opportunity to thank you for what you've done. It's an opportunity to say, we look forward to see what you will do next. Thank you.